Okay, today we're going to talk about graphing linear inequalities. So we're going to graph the solution set of a linear inequality in two variables on the coordinate plane. So to graph a linear inequality, you must have an ordered pair. That's going to tell you where to start making your graph line. And you have to have a slope. That's going to tell you how to move from your starting point. It's just like graphing a linear equation, which is why you're going to need to rearrange your inequality into the y equals mx plus b format. Now just remember, we are not going to be seeing equal signs. We are going to be seeing one of our four inequality signs in place of this equal sign. But the reason why we're going to rearrange our inequality to y equals mx plus b is that will easily allow us to see our ordered pair, know where to start, which is going to be the y-intercept. And then we're going to have to be using our slope, which we can identify easily too, so that we know how to move. So all of this is the same. This is stuff we did before the break. Here is what we are adding new when we graph a linear inequality. We have to remember that we have a boundary line, which means our line could be solid or broken. We are no longer dealing with just a solid line. And if it has a solid line in the graph picture, that means it has to match up with one of our inequality symbols that has the solid bar underneath. This is also going to help us identify points on the line that are part of our solution set, meaning they are the same as being in the shaded area of our inequality graph. If we have a broken line, it is going to match up to our inequality symbols that do not have a bar. So we're talking just our less than and greater than signs. And a point on a broken line is not considered part of the solution set. So it would be having an ordered pair that is not in the shaded area of the inequality graph. So how do we know where to shade? Well, we're going to be using a test point to help us figure that out, because that's going to be telling us where to shade. We are going to pick our own test point, and we're going to replace x and y in our inequality, and we're going to see if we get a true inequality, we are going to shade over the side of our line where the test point is. If our inequality is false, then we are going to shade on the other side of our broken or solid line. So let's look at some examples so that we can get a better idea of how this all works. Again, the front page is strictly going to be for reference when you're working on homework or on Delta Math. And the back is going to be where that information is easily seen and helps you figure things out. All right, so I have 3 times the value of x minus 2 times the value of y is less than 10. So we're going to change this into y equals mx plus b format. So I have to move the 3x to the other side. So we are going to subtract 3x from both sides. And I'm going to be left with negative 2y is less than 10 minus 3x. And then I'm going to divide by negative 2. I'm going to have y. I'm going to leave a space for my inequality. I'm going to come back to that in a second, but I'm going to finish out my division. So my first quotient is going to be negative 5. And then I have negative 3 divided by negative 2, which is going to give me a positive 3/2 x. Okay, going back to my inequality symbol. Remember from Unit 1 when we solved inequalities, we had to figure out if our inequality symbol flip-flopped or if it stayed the same. So, in order to tell if our sign is going to flip-flop, we look at the number that we divided by. In this example, we divided by a negative number, which means our inequality sign is going to flip. This is now going to become a greater than symbol. So now I have y is greater than negative 5 plus 3/2 x. Now it's in y equals mx plus b format. Now I can identify my slope and my starting point, which is my y-intercept. So my slope is 3/2, and my y-intercept is 0, negative 5. Now we want to identify the slope because, again, that's going to tell us how we are moving from the starting point. So remember, the top number tells you up or down. If it's positive, you are going up. So we're going to be going up 3, and you're always moving to the right with the bottom number. So right 2. Okay, so let's start making our graph line. Again, all of this is review. We have done this before when we graph lines. So we're going to start at 0, negative 5. And I'm going to go up 3 grid lines and right 2. Again, I'm going to repeat going up 3, right 2, and making points until I run out of coordinate plane. When I run out of coordinate plane, I go back to my starting point, and then I'm going to go in the opposite direction, which means I want to move opposite of my slope. So I'm going to go down 3, left 2 now. down 3, left 2. And you want to do a quick does that make sense check. Your points should still be in a straight line and they should be evenly spaced. If not, then you are doing something wrong and you need to check your slope and check your counting. All right, down 3, left 2 is not going to fit on the coordinate plane, so I'm done. Okay, before we would just connect with a solid line and be done, but because this is an inequality, less than or greater than symbols, we have to check to see if it's broken or solid. So I'm going to look at my original inequality sign and I notice there is no bar. That is going to match up to a broken line. So how I make a broken line is I just make dashes over the points that I have plotted for my graph line, and then I just make sure I have arrows at the end. So a broken line has to have some gaps between. It is not completely connected. All right, so now to figure out where I'm going to shade, I'm going to use a test point. I can pick any ordered pair I want on the coordinate plane as long as that point is not on my broken or solid line. So I'm going to pick the ordered pair -3, 4. Again, you can pick any input-output value pair you want. And what we're going to do is we are going to take our input and output values and we are going to plug them into the original. Now when you plug them into the original, you want to make sure you use the original inequality symbol. Do not use the one that's flipped if it flips. You want to keep everything with the original. Okay, so what I've done is I've said 3. Instead of X, I've left an empty parentheses because I'm going to fill that in with my input value from my test point. -2. Instead of Y, I've used an empty parentheses, and again, I'm going to fill this empty parentheses with my output value from my test point, less than 10. So let's look. My input value that I used is -3. So I'm going to plug that in where X used to be. And my output value is 4, so I'm going to plug that in where Y used to be. And now I'm going to do a little bit of math. So I want to figure out what is 3 times a -3 minus 2 times 4. Well, that's going to be -9 minus 8. And -9 minus 8 is -17. Again, if you are doing mental math, make sure you check with your calculator. And it's going to be less than 10. And I'm going to ask myself, is this true or false? Is -17 less than 10? That would be true. If, when you plug in your test point, you get a true inequality, you are going to shade the side of your broken or solid line where your test point is. Here's what this means. This means that I can pick any input-output pair, any test point from this side of my line, and I will always get a true inequality. All of these ordered pairs are considered solution to our inequality, and they are part of our solution set because there's more than one. If my ordered pair was over here on this side of the broken line where it is not shaded, when I plug them in for X and Y, I'm going to get a false test, which means these points, these ordered pairs on this side are not part of the solution set. Okay, let's look at the next one. So I have 3 times the value of X plus 2Y is less than or equal to 8. So again, I have to make this Y equals MX plus B so that I can graph it. So I'm going to subtract 3 from both sides. So I'm going to get 2Y is less than or equal to 8 minus 3X. We're going to divide by 2. And I'm going to get Y, 4, and then 3 divided by 2 is not going to simplify, and it's going to be minus 3/2 X. And now I'm going to check my sign because I want to see, is it going to flip-flop? So you always look at what you divided by. I divided by a positive number, which means my sign is not going to flip-flop. It is going to stay a less than or equal to. Okay. So now I know my slope. It is a -3 over 2, and I know my y-intercept is 0, 4. So I know where I'm starting. Now I need to figure out what my slope is telling me so I know how to move. And my slope is telling me, since it's a -3, it's telling me to go down 3. And remember, with the bottom number, we always go to the right. So that's going to go right 2. Okay, now I know how to make my graph line. I'm going to start at 4. And I'm going to go down 3 grid lines, right 2 grid lines. Down 3, right 2. Down 3, right 2. Down 3, right 2. Down 3, right 2. And I'm going to repeat that until I run out of grid coordinate plane. And when I do that, I'm going to go back to my starting point, and now I'm going to go in the opposite direction, which means I go opposite the two directions my slope was telling me to go. So now I'm going to go up 3 and left 2. And again, quick check, they should be in a straight line. Up 3, left 2. Okay, I'm going to check my line type. Should it be broken or solid? So I'm going to go back to my symbol, and if it has a bar, that means solid. So these points have to be completely connected. There cannot be any gaps or empty spaces in my graph line. Completely connected. That's a solid line. All right, just like before, we are going to have a test point. And again, I'm going to pick any point I want. This time, I'm going to pick the point 7, 3. 7, 3. So my input value is 7, my output value is 3, and now I'm going to do the exact same thing. I'm going to plug in my input and my output values. Into my original. And again, make sure you use the original symbol. You do not want to use the flip symbol if it flips. You always want to use the complete original inequality, including the symbol. And now we're going to plug in our x and y. So my x value is 7, so I'm going to put 7 where the x used to be. And I'm going to plug in the 3, and the 3 is going to go where the y used to be. So now I've got 3 times 7 plus 2 times 3. Well, 3 times 7 is 21, and 2 times 3 is 6, so what is 21 plus 6? 27. And less than or equal to 8. So I'm going to ask myself, is 27 less than or equal to 8? Is that true or false? And hopefully you said false. So if you get a false inequality, here's what you're going to do. Since this test point does not give me a true inequality, this side does not contain the solution set. It contains, the solution set is on the other side of this graph line. So we are going to shade on the other side of the solid line from my test point. Okay, so here's what that means. This means that any point in this shaded area, when I plug them into the original inequality, I will always get a true inequality. If I plug in any ordered pair from this side of the solid line where it is not shaded, I am always going to get a false inequality, which means these points are not part of the solution set. Okay. So, last two examples. So now we're going to look at what happens if I have one of those special lines like a Hoy or a Vex. So the first one I have is x is greater than or equal to -5. So I notice I am missing the y variable. So that means it is not a Hoy, it is a Vex. So I know some things about this graph picture. I know that my line is vertical. The u tells me that my slope is undefined because my line goes up and down. And the x is telling me that my equation is x equals an input value. So even though I'm using less than or greater than, it still works the same. That number is an input value. So my input value is -5. Or all my input values, I should say, are -5. Okay, so now I'm going to make my graph line. So I'm going to go to where my input value is -5. And now I just have to decide, is my vertical line supposed to be a solid vertical line or a broken vertical line? And I'm looking at my symbol. I see a bar, that tells me solid line, so I know that my vertical line in my graph picture has to be solid. Now I just have to figure out where the shading is, and I'm going to use a test point just like I did in my first two examples. So I'm going to pick a test point, 2, 3. Looks like a good one, 2, 3. And I'm going to plug my input and output values into my original inequality. Well, it's x is greater than or equal to -5. So the only input value I'm going to use is the input value that's going to replace x. And that input value is 2. I don't have a y to replace, so that 3 is not going to be used. So I really have 2 is greater than or equal to -5. Is this true or false? And this would be true, which means that the side of the solid line where my test point is where my solution set is. So I'm going to shade on the side of the solid line where my test point is. All of the ordered pairs on this side where the shading is, all of these input-output pairs, when we plugged them in, would be true inequalities. all of the input-output pairs on this side of the solid line where it is not shaded are not solution set points. Okay, let's look at the last one. So I have y is less than 3. So I notice I'm missing a variable, and that variable is x, which means it cannot be a Vux line. It is a Hoyle line, and I know that my graph line has to be horizontal. The O tells me that my slope of my line is 0, and the Y tells me that it is Y equals an output value. So I know that that number after the less than or greater than sign is an output value. So this 3 is an output. Okay, so I'm going to go start graphing my line just like we've done in all 3 examples before this. I'm going to go to where my output is 3. And now I need to decide, is my horizontal line supposed to be broken or solid? And that's where you look at your symbol. Bar means solid, no bar means broken. I don't see a bar, so it's broken. And all I'm going to do to make a broken line is just leave gaps when I trace the horizontal grid lines. Just leave some gaps in there so it looks broken. Now I have to figure out where the shading is. And again, we're going to do just like we've been doing. We are going to use a test point. So I'm going to use the point -4, 5. If you want to choose the same test point over and over again, that is fine. The only thing that I ask is that your test point cannot come from your broken or solid line. It has to be on one side or the other. That way you know where to shade. Okay, so we're going to use -4, 5. We're going to plug it in. So I've got y is less than 3. Okay, so I've got to plug in. So I'm going to use my output value only, and that would be 5. So I have 5 is less than 3. Is that true or false? And that is false. 5 is not less than 3. So I know that I cannot shade on the side of the line where my test point is because that was false. So my solution set is on the other side of the broken line. And any ordered pair, when I plug in the output value, I am going to get a true answer when I use these input-output pairs, which is why these are in my solution set. All right, that is how we graph inequalities, and that is how we determine, using a test point, which points are considered solutions and which points are not.